Thank you, Marty. So I am here to talk about and introduce the Harmony Core open source project. It's not really introducing anymore because we've said the name a couple of times, so it's not quite the right title slide, but I'm here to talk about RESTful Web Services and our framework for doing it. So what is Harmony Core? Harmony Core is a framework that consists of libraries, so binary code, code-gen templates, and conventions that allow you to expose Synergy logic and data as a RESTful web service using OData and ASP.NET Core. So hopefully I've gotten enough buzzwords and acronyms into my description there that everyone's happy and good with its forward-looking acronym usage. So we have a goal, and this goal has changed throughout time, but I'm going to start at the first goal that we had, which was I need to expose Synergy data over the network. So we have a bunch of different answers to this question. So why did we need to make yet another answer to this question? So the comic I have up here is the XKCD that says we have 14 competing standards. 14, that's ridiculous. We need to develop something that works for everyone and everyone will use it. Situation, there are 15 competing standards. So why did I decide to make number 7 on the list of competing standards? And I'm going to go through that in just a moment. So part of the reason is because the goals have changed throughout time. So certain solutions work better for different goals. So our goal has changed from just exposing Synergy data to exposing Synergy logic and data over the internet. Access Server Plus is great. It transmits data quickly, but it's not really the sort of thing that you'd want to put directly exposed on the internet. It sends a lot of data across, which isn't particularly internet friendly. The protocols that it uses are not particularly internet friendly. So, that's not really an option if we're talking about exposing things directly over the internet. Something like SQL replication, if you're just exposing data and it's local and you trust everyone involved, that's a great way to expose data. But if you're going out over the internet and you don't trust everyone, you don't really want to give everyone access to the internals of your SQL database. So again, that solution is no longer available. And with the relentless march of time, our goals change again. And it's changed this time to I want to expose that Synergy logic and that data over the internet. And I also need to do it with tens of thousands of concurrent users. So a couple hundred users, no big deal. It's actually pretty easy to scale to a couple hundred users. Even if you've made poor decisions everywhere, you can still manage to scale to a couple hundred users simultaneously. But tens of thousands, every choice becomes the most important choice in order to get to that goal. So that cuts down on our list of options significantly. There's just a lot of really specific things that you have to do in order to maintain that performance. So what we're left with here is basically you can write it yourself. So there's lots of different technology options for you to write it yourself. You can use Web API 2. You can use ASP.NET Core, like MVC. You can use WCF or ASMX. These are all acronyms that have shown up on slides here throughout the days and throughout the years. So they're all viable answers to this question, but you have to write it yourself. So all of those performance decisions, you are responsible for those performance decisions. So if you're writing this, you have to come up with things like, how do I manage channels? Maybe how do I manage app domains? How do I make sure that everything's getting used on the right threads? I have to come up with some kind of at least vaguely consistent scheme for how I do endpoints so that people aren't talking to completely different endpoints for every single thing they want to talk to me about, because it's a lot of mental overhead for the people that are using your API to think this API works totally different than this API, which works totally different than this API. And you probably are going to have to put in some kind of query interface, because people ask for one feature and then they start using it for a little while, and while they're writing their app that's using your API, and then they say, but I'd like it to also do this. And so you have to go back and make changes to the code. So it's a lot easier if you can put some kind of query API in there so that you're not rewriting your endpoints every time someone asks for just an incremental feature addition. And your front-end devs keep sort of pestering you and saying, like, I don't want to write all of this connector logic in JavaScript. Can you write me some kind of like code generator that generates these client libraries for me so that I don't have to do it? It's a pain, and I don't want to deal with it because I'm a front-end dev. So we have a new goal, right? We need to expose synergy, logic, and data over the internet with tens of thousands of concurrent requests. We need to collect performance metrics and present configurable logging because management loves metrics and everybody loves logging. We need to enable some advanced queries, but we need to be able to control the security for those queries. We need generated client libraries in the language of your choice. And while you're at it, what's this .NET Core thing that everyone keeps talking about? It'd be really cool if we could do something with that. So we did these things. And we called it Harmony Core. So first off, I'm going to show you an example of it working out in Azure. So this is just a chunk of HTML that's sitting at the front of our web service, but this is actually running out of our Harmony Core web service. And this is running in Azure in the cloud. It's not a VM, it's a web service. So there is no Windows install, there's no patches. I don't manage anything internal to the server. I've just deployed my code and it's running out in Azure. There's no Synergy install here. The licensing is done via environment variable config. And we are VNetted to a Synergy license server that serves up those licenses. But there's no actual install on the web service itself. So what does this thing do? I can click on various things. I can pick up some metadata like this. This is Swagger doc. Swagger docs are a really helpful way of describing what your API does. And in particular, this handy website that comes along with those Swagger docs lets us actually test out the API just in the browser, straight from the web service, without having to actually do any coding on our server side. So you can see there's lots of all these sample endpoints and stuff like that. And I'll just real quick pick one. Like, so I just sent out a request to get me all of the customers. I think that was customers. Yes, all of the customers that we have in data, and it's returned me this rather large pile of JSON with all of the information about that customer. And there's a lot more that you can do with this endpoint, and you guys can feel free to go to harmonycoreapp.azurewebsites.net and poke and prod it and maybe break it to your heart's content. But anyway, I just wanted to show it working as a thing before I tell you guys how it works and what it uses in order to work. And just to prove that this really is running out in Azure, I mean, it's kind of proving that it's running out in Azure. Here is our Azure console, and that is for this running web service. And I have the Process Explorer running. And it tells me that our web service is using 5 megs of RAM, which I actually think is a pretty amazing number for a web service that's doing as much stuff as this is doing. So I'm really happy with that number. But there's, all sorts of other info in here because it's Azure Console. You got graphs. You can see my requests there, kind of. I think you guys can see that. But yeah. How did we do this? What parts did we use to make this? So Harmony Core is built on top of ASP.NET Core. So Steve has mentioned that a big part of the drive in .NET Core and ASP.NET Core has been performance and moving fast. So they are quickly making it faster. It's already fast, and they're just making it faster with each release. We are currently on the 2.1 release, which is a really important moment for .NET Core because it sort of represents when they've not only got the features and functionality that's required for prime time, but they've had a little bit of time to iterate on those features and functionality, and things are actually starting to get really polished and very usable. We are a RESTful web service. So REST stands for representational state transfer. And much like you heard yesterday, we've been making the case for RESTful web services for a few years, and there's no end in sight for that case being made. So we are going to keep saying that you should make RESTful web services like this one. We are also built on top of OData. Steve mentioned this as well in the earlier presentation. It's a set of standards defined by OASIS, that's the group that owns the standard, that lay out how you interact with a web service. So one OData web service is not going to be completely identical to another OData web service. Obviously there's important differences, the actual entity names that we're talking about, but the ways that you interact with those entities is going to be the same across different OData providers. So it brings you into an ecosystem where people understand how to use your web service. There's tools around how to use your web service, code generators, that sort of thing. And these are the same standards that are used by SharePoint internally, SAP, Microsoft Graph, Salesforce, Microsoft Dynamics, and a lot of others. So the standard is currently at version 4. There's a couple of addendums to that version 4, and Harmony Core is on version 4 with those addendums. We are also built on EF Core. So Entity Framework, we provided a mostly read-only EF 1.0 provider back in 2008 that was layered on top of our XFODBC support. And things have changed a lot over the last 10 years. So we're currently on EF Core 2.1, and the transition from EF 6 to EF Core was a complete rewrite of the entire product. And they basically just took all of the lessons that they had learned over the prior 8 years and decided they weren't going to make those mistakes a second time. So there's a big focus on performance and scalability and how you actually squeeze that last ounce of operations out of it. So we've created an EF Core 2.1 provider. And the way we've created it is very different than that initial 1.0 provider that we had back in 2008. So instead of layering on top of XFODBC, we use a lot of code generation. So your repository is an important part of our provider. We use the Synergy Select class, which didn't exist back in 2008, so we obviously couldn't have used that back then. We use the Symfony File I/O class. So we are not a read-only provider. We are a read and write provider. We use a lot of concepts and ideas from Symfony Harmony, which we've been talking about, again, for years. And this is just bringing those into Harmony Core. And just general improvements to the design of EF that make being an EF provider a lot more friendly to database providers like Synergex. Right, so all that stuff comes together, and it works together as a whole really well, but parts can also be used independently. So if, for example, you see the EF provider and you say, yeah, that sounds great. I want to use that, but I don't want to use OData. Fine, you can use that. It works by itself. You don't need to take the dependency on OData or ASP.NET Core at all. You can use these things completely independently of each other. A lot of the complexity, so when you're making framework choices, there's a lot of complexity caused by configuration. Everyone has different needs. But there's a pretty good starting point that's most people want things to behave this way. This is our expectation for what we think our customers are going to want. So a lot of the complexity of configuration is hidden behind what at least we currently think are sane defaults. We are built using .NET Standard 2.0. So anywhere where Synergy.NET runs, Harmony Core will also run. So that works on the regular framework, that works on Mono, that works on .NET Core. And you don't have to recompile or anything like that. You just deploy it to a machine that has that running framework on it, and it runs. We are developed in the open. So we're out on GitHub. You can see our issues list and our wiki documentation and all of our source code. And you can see Steve and I constantly jamming new pull requests and pushing new source code out there. And you guys feel free to also put in issues and comment when we're talking about design decisions and those sorts of things. We want the conversations to be occurring on GitHub rather than having them occur internally over email or something sort of opaque to all of you. We want the decision-making process in this project to include all of you who are essentially stakeholders. So please check that out later on. Harmony Core also integrates seamlessly with ASP.NET Core authorization and authentication. So security is very, very important to everyone. And it's so important, in fact, that we don't want to be responsible for it. We want someone else who's got a lot more experience with security to be responsible for it, and so that's what we do. Microsoft has a framework, and we use it. And anything that plugs into that framework works with us. So we think that sort of takes away a little bit of the gray area on security, because you can just follow standards and practices and do what everyone else is doing. That has lots of security researchers looking at it and trying to poke holes in it. And so, yeah, sort of best of breed security. One of the things that's an important tenet in OData and in web services in general that are RESTful is how do you deal with concurrency? So if one user is operating on a resource and another user is operating on the same resource, how do we reconcile this difference? We can't just hold a lock on that resource between web requests, because the second web request may never come, and then you just have this resource that's locked out there forever. So we use optimistic concurrency, and essentially what that means is that we hope nothing bad happens, right? That's what optimistic means. So we hope nothing bad happens, but if something bad does happen, if you do get stepped on, we need to know that it changed out from under us, that the world is not the world that we thought it was, because we weren't holding a lock on that record. So GRFAs are useful for this, and they are manifested in the actual API as e-tags. So there's a little token that says, this is the state of the world, this is what this thing that I'm working on looked like when I decided that I was going to start working on it. And when I go make a change to that thing over my RESTful web service, if the tag doesn't match, then I need to deal with that concurrency conflict. It's not the record that I was operating on previously. So e-tags are a way to keep you from stomping on yourself. Additionally, and this is really important because you have to be able to fail transactions when GRFA is out of date, we have implemented transaction isolation in our EF core provider. And that's got different levels of isolation depending on your needs and their performance characteristics to those levels of isolation. So we have read uncommitted and read committed. And talk to me later if you think you need any of the higher levels, so that I can understand what your actual use case is and see if we can come up with something that answers your requirements. We bundle up a lot of our functionality in the concept of contexts. So contexts are just chunks of your logic or chunks of configurations, already set up things that we can use dependency injection to pass throughout the various bits of your application. So the idea is that you should not, if you're writing a piece of logic, ideally you would not have to know where your EF core context comes from. You wouldn't need to know where your usernames and passwords come from. They'd be handed to you. So dependency injection is a way of doing that without you having to be aware of where these things come from. Someone else registers them, and you just ask for them, and they show up. So dependency injection is used throughout Harmony Core, and it's supported everywhere where it sort of makes sense. If we're creating an instance of your code, we will do dependency injection on the constructor for that code, and you'll have whatever functionality you've asked for in the constructor. We also use those contexts inside context pools. One of the big parts about how you achieve that tens of thousands of concurrent users is you have to pool things a lot. XF Server Plus pooling, it can be a mildly unpleasant experience to configure. So the idea here is that the context pools are no configuration other than saying, yeah, I would like there to be 3 of them at a minimum and 150 of them at a maximum. Like that's the extent of the kind of configuration that you should need to do on these. And then they just work, right? So every time a context gets used, it comes out of the pool. And when the request is over, it goes back into the pool. So this works for isolation levels. We won't give out a context that's supposed to go out on thread number 1 to someone who's asking for a context on thread number 2. We will only give that out to the appropriate thread. We'll only give that out to the appropriate session if you have session state turned on. So what do you get out of it? One of the things that you get out of it is CRUD for free. Richard commented on CRUD in his previous presentation, but that's create, read, update, and delete. So you can create records, read records, update records, delete records. That's what CRUD does. But what do you need to do in order to get that functionality from us? Probably nothing if you have a repository that's already set up. You'll need primary keys defined for your records. They will need to have the correct types on those primary keys. If you have an alpha key in your file and the structure is actually decimal and the data is actually decimal, you really should change that key type to actually match what you're using in code. Everything works better that way. But your structures and fields do need to be up to date between what's actually in files and what's in your repository. And you also need to define the actual files in repository. Once you have that repository, we have code gen templates that make everything for you and give you customization points. So we ideally don't want you to have to make changes to those templates. If you find yourself needing to make changes to those templates, you can make them, but then tell us about it so that we can reincorporate sort of your concept, or we can put in an appropriate hook so that you don't have to change templated code. And that way, when we come out with a new version of the template, you're not blocked, right? We want the upgrades of the product to be as seamless as possible. So things like templates can just get updated with new features, functionality, and performance without you having to say, but I have to do all this work in order to take the next version. So we want to try and isolate breaking changes from you guys as much as possible. And the best way to do that is for us to put in extension points rather than you having to customize the templates. The next layer of functionality that you can get is CRUD with queries. So you need a little bit more out of your repository in order to get this. So you still have to have keys defined and files defined and structures and fields defined. But now you need all of the keys that you care about to be defined. All your foreign keys that you care about need to be defined. And as many relations as you want to follow need to be defined. So relations are an important way that we essentially take the relations from your repository and they become exposed as navigation points. So if you have a customer and customers have a set of orders and you've defined that relation, that means that we can use a select join for you under the hood to when someone asks for customer A and all of their orders, we go grab customer A and we follow that navigation point and we go grab all of the orders, all in one operation, all at once. So relations are a pretty helpful way to expose more than just one file at a time through the CRUD interface. So once you have these relations and the keys and the foreign keys, the code-generated templates are going to now support a $expand operator. So that's how you follow those navigation points and how you get single items or collections of items that you can also filter on. So that brings us up to filtering things. So that's like where customer number is 5 and they're from the state of Nevada. You have expand support, which is that sort of select join through a RESTful Web Service. Select says, I only want these certain fields, and I don't need to transmit all of the other data. So that's helpful for performance. And order by, so you can choose how the returned results get ordered. The next level of stuff that you can do with it is directly exposing logic. So CRUD is useful, but I think most of you probably have a little bit more logic in your applications than just creating records, updating records, and reading records or deleting records. Complex business logic is sort of why you're here. So you probably want to directly expose some logic in your web service as well. And there's 2 ways to do that. One is you can just write custom controller code so that inherits from either a web API controller or it inherits from an OData controller. And then you just implement the endpoints and you take parameters and you return results, and the framework around it will call your routines, it'll serialize that data, do any security work that it needs to do, and the user will get back the result of your logic that was running. The other option is we're calling Harmony Sprock routing conventions. So you attribute and register a class, and you tell it what endpoint that it's going to live at. And it gets exposed as either an OData function or an OData action. So functions are a read-only concept. So you're asking for data, you're passing parameters, and you expect to get a result, but you're promising this will not change anything on the server. And actions take parameters, return results, but will change things on the server. Optionally, with this Harmony Sprock routing convention, you can directly expose a context, and those contexts can come from a pool. So this is a helpful way to have the isolation levels that come from the contexts, but have it fold directly into actually routing the web service requests. So what do you do if it can't work in process? So those previous options for exposing logic, those are in-process options. How do we actually get either same machine but a separate process, or a remote process that's actually running your code for you? So we came up with an answer to that question, where we build target programs and they run over on wherever you want to run them, either on your local machine in a separate process or on a remote machine with SSH. And then we use standard in, standard out to talk with JSON messages back and forth. So that's a chunk of framework that we provide for traditional Synergy. and then it just calls your underlying logic that you've had forever. And there's not really a whole lot of restrictions on that because it's just running in traditional and it's process isolated. So why did we make that? We sort of already have that in Access Server Plus, but IT admins really like protocols that they know. Their favorite protocol of an IT admin is no protocol. Like, don't touch the network. They don't like that. But in the absence of that, they really like standard protocols that they understand, that they use every day, that they know how to secure these protocols, and they know what to expect from them. This uses SSH to do our remote, or no network at all if you're running on the same machine. Right, so this means that you can run traditional Synergy on a remote VMS, Unix, Linux, or Windows server. Or you could run .NET code that needed to be process isolated. For example, if you needed environment variables to be passed back and forth all across your application, those are not something that's isolatable inside of a process. You would have to run those in a separate process. And this is a way to do that communication. And any other code that can follow our communications protocol. So we have docked our communication protocol. So if you were so inclined, you could make a server for that protocol yourself in some other language on some other platform, or you could make a client for that protocol that's in some other language on some other platform, and mix and match them as long as they follow the standard. So again, security is really important. One of the reasons for the SSH, because security is important. But on the actual front end of the web service, I just am going to talk a little bit about how the security actually ends up getting implemented. So we're using ASP.NET Identity. It's very, very customizable. There are a lot of different persistence mechanisms and providers. So that's ADFS, which is the Active Directory provider that you would have on premises. There's Azure AD, there's OAuth, and there's a lot of other providers, as well as custom providers that you can use there. What that gives us is role-based or claims-based authentication. So instead of saying user Fred has access to this piece of API, you say managers have access to this API. And you're in control of what those roles are. If you're deploying to non-English speakers, they might not like the word manager and user. They might have some other word for whatever reason for users and password or users and managers. So you can pick whatever names you want for those roles, and you just tag the bits of code that you care about securing, and say they have to have this role in order for it to work. But the way that works is they ask the provider for a JSON web token, and then whenever they hit your website or your web API, they're going to pass that JWT in, and then it gets authenticated, and we check against what roles it's making claims against. Here's a quick flow overview for how that actually works. We have our client application over there on the left. We have an authentication server, which is separate. It could be running anywhere. And then we have an actual protected service. So first off, they go talk to the authentication server. Somehow or another, they give it a username and password. And it gives them back an access token. That access token contains their set of claims, which says these are the roles that this JWT is good for, and this is the scope that this JWT is good for. They send that request off to your RESTful API, and then we decrypt that token and see what the claims are, and either kick them out because they don't have the right permissions, or carry on with the result. Internally, that JWT looks like this. It's broken up into 3 parts. So there's this red section here, which is actually the set of claims. And the blue section is an encrypted chunk, or it's a hash encrypted hash. It's a crypto goodies that tell us that the stuff that's being claimed up above is in fact true. And hasn't been falsified. No one has changed it. No one's changed the JWT to claim things that they weren't allowed to have to begin with. So that blob of red gets decoded into the JSON that's on the right. And it's mostly just telling us what algorithm we're looking at, who the authorizer is, what the scope is, and then the set of roles, as well as when this JWT expires. Expiration is important for security, because you don't want people to just get a token and then be able to use it forever. So those tokens always have expiration dates on them. So the important part is, of course, that role in the scope. Licensing. So Harmony Core itself is BSD 2 clause, so you can use it to do whatever you want. There's not really any restrictions on that whatsoever. You don't have to tell people that you're using our stuff. You just use it. Regular Synergy runtime licenses will be consumed by the running processes. So if you've spun up a process, it will use a Synergy runtime license. Same is true with Synergy.net. We are looking into ways to make runtime license compliance easier using this, but we're not thinking that this is in any way an enforcement mechanism. So don't worry about this getting in the way. It's literally just here to help you do the stuff that you want it to do. So I have a quick demo of what you do if you have traditional Synergy and it's running on VMS, and you want to expose it out as a RESTful web service. So that's my Postman. And it's not running. I mean, it is running, but it's not running inside Visual Studio. But this is the Visual Studio project for Harmony Core, and it has our unit tests in it and stuff like that. But this is what I'm running currently. And one of the parts of it is this traditional bridge. There's two projects there. Two of them are traditional projects. One of them it's the placeholder for your user code, and the other is our library portion of functionality. So you just reference our library and build a DBR, and that's how this thing works. But I have it running, and I have my VMS emulator that's running on Steve's laptop, running there in the background. And this is set up. It's telling us all of the IOs that are happening for the process that we've started over on VMS. And here's my URL. I've just picked a particular endpoint, and I called it VMS. That was a user choice on my part. It's not like we're enforcing anything there. And then it's going to call the getAllCustomers function. And the parentheses say I'm a function, not an action. So that's just an easy way to recognize the difference. So I fired that off. I think we saw a bunch of IOs happen over here on the right. And it returned a bunch of JSON data. So that sent a request to our ASP.NET Core web server, which then forwarded that request off through a pool of SSH connections out to the VMS emulator that's running locally on this machine. And it asked that DBR very nicely, could you get me all of the customers and return me back that data in a JSON format? The DBR read that request, processed it, dispatched it out to the user code that actually goes and reads all of those customers, ran it through a serializer, and returned it back over standard out, which we got in our web server, and then we forwarded it on to the requesting user. So being in the middle with ASP.NET Core means that we can do all of that security validation using the frameworks, and it doesn't have to get done, or it can be done in a slightly different way on the VMS side. Why does this matter to you? We think it makes your life easier. The less code that you have to write in order to get web services is the less code that you have to write in order to get web services. So that's a big plus. Security, I think everyone in here knows that security is important. There's You don't want to be the one that pops up on the nightly news with people having compromised your API and gotten in and done things that they shouldn't have done. So putting that security layer on there is important. Open standards are really nice. It's helpful to have a consistent way to interact with things and know that the greater community at large has spent a lot of time thinking about these open standards, and you're able to best take advantage of those. The library is built with performance best practices in mind. So all those very difficult things that we stand up here and say, oh, you guys just have to do blah in your application and it'll run so much faster. We just do those for you because we know they're hard. So it works out well when we can apply those best practices for you. Especially with the CRUD operations with query support, we think that offering that out will result in less change requests. So when someone's first using your API to develop some new application, they don't really know what they want your API to do. They might have a kind of an idea of the sorts of operations that they want it to do, but when they actually build the application out, they're going to run into things and they're going to say, yeah, I need you to give me a new endpoint that does X, Y, and Z. And we think the CRUD with queries will cut down on those change requests. So they can just use the queries, either short-term or long-term, to answer whatever the question is that they need. And either you can incorporate that later in a later version, once they've really figured out what they actually want your API to do, or you can just keep using the CRUD with queries to provide that support. Less change requests means you're happier, you're interacting better with the people that are integrating, and they're not having to wait on you. So using standards, getting generated clients, not having so many change requests, that means happier integrators. So you'll get better clients, you'll get better third-party support for whatever it is that someone's consuming your API for. And also, we think that the framework has a lot of flexibility in it. So the customization points, the ability to replace our features and functionality, the fact that it's open source means that if you need to make changes, if you have a better idea for how something needs to get done, we can do that. What's next? This is just sort of a laundry list of things that we're working on. And actually, yesterday I knocked off one of the items on this list. It's still there because I didn't want to change it for my slide deck. But we're rapidly working down this list and trying to offer the things that we think that you want. But now that you're all hearing about this, we want to know what the things are that you want rather than just thinking we know what you want. So please talk to us. Make issues on our GitHub. So that we can actually respond to them and make the product what you actually want it to be. Here's a couple of additional links of interest. So that's basically just all the technology bits as well as our GitHub. One of those is a sample usage of the API by itself, and the other is the actual project, which also contains a lot of samples.
So the first question is, what options are there for specifying file locations from repository, i.e. we have multiple company data file sets?
So by default, it's easiest to use very static, fixed file names that are stored in your repository because then CodeGen can do it for you. But if you have a more complicated scenario than that, you just have to inherit from our file channel manager, and all the file channel open requests come through you, and that gives you an opportunity to decide what to do with that. If someone asks for XYZ, you know what that means, and you'll turn that into an actual file open, rather than us having to assume what it is based on what's in your repository. So you can completely replace the file open mechanism, and then the whole system will change its behavior based on that.
Okay. On OpenVMS, are processes on different nodes considered local or remote? We tend to distribute services and processes across multiple nodes.
I'm not sure if I'm going to answer this correctly. When I mentioned local versus remote, I was not referring to local on VMS. I was referring to local to the ASP.NET Core web server. So on the same machine as the ASP.NET Core web server. Everything running on VMS is remote to that web service. It is not running on the same machine. Node 1, Node 2, Node 10, they're all the same remote as far as I'm concerned. I'm just opening an SSH connection and leaving that SSH connection open based on configuration and asking it to do work. So wherever that thing ends up, that's where it's doing work. Thank you.